So, response of undamped second order system for unit step input we will see here. So, this is unit step input, input is step input, unit step input. So, here this R of s can be written as 1 by s, and given that system is undamped system, undamped system means zeta is equal to 0. So, by applying these two conditions, the transfer function now will convert into C of s by R of s is equal to omega n square divided by s square plus this term will become 0 and omega n square. Then the output C of s can be written as R of s into transfer function. So, this R of s is equal to 1 by s into the transfer function is omega n square divided by s square plus omega n square. So, therefore, the C of s can be now written as omega n square divided by s square plus omega n square into s, which can be written in terms of partial fractions like a by s plus b by s square plus omega n square. So, now a and b can be obtained by using this partial fractions method. So, a can be obtained as omega n square divided by s square plus omega n square by putting s is equal to 0. So, therefore, it will become omega n square by omega n square, which is equal to 1. And similarly, b can be obtained as b is equal to omega n square divided by s by putting s is equal to j omega. So, therefore, omega n square divided by j omega n j omega. So, therefore, this will be minus j omega, which is equal to minus s. So, here I have taken s square plus omega n square is equal to 0, then s square is equal to minus omega n square, and s is equal to minus omega n square under root. So, therefore, s can be kept as j omega. So, this is the way I have taken here, s is equal to j omega, and substitute now here, then you will get C of s as a by s plus b by s square plus omega n square now will be 1 by s minus s by s square plus omega n square. So, if I want to get C of t, I have to do the inverse Laplace of C of s. So, therefore, Laplace inverse of 1 by s minus s by s square plus omega n square. So, this will be now 1 by s will be 1 minus s by s square plus omega n square is nothing but cos omega n of t, cos omega n of t. So, this is the time response of undamped second order system for unit step response or unit step input. The waveform can be written, and we can draw this waveform as this is the time and this is the C of t. So, the waveform will be like this. This is a cos function like this. So, this is 1 unit step input, and this is the peak values of this cos function, this is 2. So, using this equation, the response of this undamped second order system for unit step input is sketched as this cos wave function, and it is observed that the response is completely oscillatory. So, the response is completely oscillating in nature, oscillatory response. So, but every practical system has some amount of damping, hence this undamped system does not exist in practice. So, practically this system does not exist, because every system will be having certain damping. So, generally this undamped system will never exist in practical case. The next topic is response of underdamped second order system for unit step input. So, this is important for examination point of view. Response of underdamped system, underdamped second order system for unit step input. Response of underdamped second order system for unit step input. So, we know that the transfer function is C of s by R of s is equal to omega n square divided by s square plus 2 zeta into omega n into s plus omega n square. So, here the input is R of s, which is nothing but 1 by s step input, and the value of zeta is, it is lying in between 0 and 1, so called underdamped system. And also we know that the roots of this underdamped system are minus zeta into omega n plus or minus omega, so j omega d. The roots are minus zeta omega n plus or minus j omega d. Omega d is the damped frequency of oscillations. So, substitute these values here, then C of s is equal to R of s into the transfer function. So, this can be written as 1 by s into the transfer function is omega n square divided by s square plus 2 zeta into omega n into s plus omega n square. So, by expanding this in terms of partial fractions, this will be a by s plus this is bs plus c divided by s square plus 2 zeta omega n into s plus omega n square. As it is a complex function, so the partial fraction will be bs plus c. From here, a can be obtained as omega n square divided by s square plus 2 zeta omega n into s plus omega n square by putting s is equal to 0. So, there by value a will be, so this term will become 0. If I put 0, this term will become 0. So, this a value will be omega n square divided by omega n square, which is equal to 1. So, for getting b and c, we have to compare the equation for the coefficients of s square and s. So, therefore, by cross multiplying, we will be having the function as, after substituting the value of a is equal to 1. So, here I am writing on cross multiplication after substituting a value as 1, we will be having the function as omega n square is equal to s square plus 2 zeta omega n into s plus omega n square plus bs plus c into s, bs plus c into s, or I can further reduce this one as s square plus 2 zeta into omega n into s plus omega n square plus bs square plus cs. So, this is the equation, let me take it as 1. So, equating the coefficients of s square on both sides, will get 0 is equal to 1 plus b. So by that b is equal to minus 1. And here the next case, equating the coefficients of s. So therefore here we will be getting 0, which is equal to 2 zeta omega n plus c. From that, c can be written as minus 2 zeta omega n. So here now the transfer function will be c of s is equal to a is 1, so 1 by s minus, so this is minus 1 and this is minus 1. So I am just taking minus as common, minus s plus b is equal to 1. So therefore s plus 2 zeta omega n divided by s square plus 2 zeta omega n into s plus omega n square. So for this, let us add and subtract zeta square into omega n square in the denominator of the above equation. So what happens? Let us see now. So c of s will be now here 1 by s minus s plus 2 zeta omega n divided by s square plus 2 zeta omega n into s plus, I am adding and subtracting this value. So zeta square omega n square minus zeta square omega n square plus omega n square. So now here this will, if we observe this, this is nothing but s plus zeta omega n whole square, a square plus b square plus 2ab form. So by computing this one, I am writing here c of s is equal to 1 by s minus s plus 2 zeta into omega n divided by s plus zeta into omega n whole square plus omega n square minus zeta square omega n square. So this is plus omega n square minus zeta square omega n square. So from this we can take omega n also as common. So therefore 1 by s minus s plus 2 zeta into omega n divided by s plus zeta into omega n whole square plus, take omega n as omega n square as common. So this will be 1 minus zeta square. Okay. So here I can divide this equation here. I can divide this numerator as 2 zeta omega n is there. So I will divide this equation as 1 minus s minus s plus zeta omega n divided by s plus zeta omega n whole square plus this omega n square into 1 minus zeta square I am writing as omega d square minus zeta into omega n divided by, so same s plus zeta omega n whole square plus omega d square. I just divided this plus 2 zeta omega n in two terms, zeta omega n. So here this is minus, so here we will get minus and here we will get minus, and this is omega d is equal to omega n into root of 1 minus zeta square. So if you apply square on both sides, this will be now omega n square into 1 minus zeta square. So this I have replaced it here. Now for this equation, let us add and multiply. Let us multiply and divide omega d in the third term of the above equation. So therefore this will become 1 minus 1 by s minus s plus zeta omega n divided by s plus zeta omega n whole square plus omega d square minus, I am just multiplying and dividing here. So zeta omega n divided by omega d into, or I can write like this. Now I am multiplying this omega d here in the numerator, and I will be having s plus zeta omega n whole square plus omega d square. So I just multiplied here and I divided the same term, so there is no change here. So therefore now let us conclude here. So this is our C of S. Now I have to get the time domain specification. So the time response in time domain can be obtained by making inverse Laplace of this C of S. So if I apply inverse Laplace to this function, what happens means C of t is nothing but inverse of C of S, which can be Laplace inverse of 1 by s minus s plus zeta omega n divided by s plus zeta omega n whole square plus omega d square minus zeta omega n divided by omega d into omega d s plus zeta omega n whole square plus omega d square. For this I have to apply inverse Laplace transform. So therefore C of t will be now, so 1 by s is nothing but 1 minus, so this one e s plus zeta omega n and s plus zeta omega n whole square plus omega d square. So this can be written as e power of minus zeta omega n into t cos omega dt, and coming to the third term, zeta omega n by omega d will be as it is, and for this is the sine term e power of minus zeta omega n t into sine omega dt. So this is the time response of that above function. So here further I can reduce this one, 1 minus, I can take e power of minus zeta omega n t as common, e power of minus zeta omega n t as common, and I am just taking this omega d also in the denominator, so that omega d into cos omega dt minus sin omega dt into zeta. So there is a zeta here. So here 1 minus e power of minus zeta omega n t divided by omega d, I can write so, or else I can simplify here itself. I can simplify like this. So here this is the 1 minus e power of minus zeta omega n t. If I take common here, and this will be cos omega dt minus, I have taken this as common, and zeta into omega n sin omega dt divided by this omega d I can replace with omega n into root of 1 minus zeta square. So therefore here this omega n and this omega n will be gets cancelled out, and here now I can take it as common, 1 minus e power of minus zeta omega n t divided by root of 1 minus zeta square. So, therefore, here root of 1 minus zeta square into cos omega d t minus zeta into sin omega d t. So, this equation now from the triangle here. So, this is a triangle here, this is a zeta and this is a theta, and this is root of 1 minus zeta square and this is 1. So, from this triangle I can simplify the above equation as root of 1 minus zeta square can be replaced with sin theta and zeta can be replaced with cos theta. So, in the above equation C of t can be written as 1 minus e power of minus zeta omega n t divided by root of 1 minus zeta square. So, this root of 1 minus zeta square can be replaced with sin theta into cos omega d t plus this zeta can be replaced with cos theta into sin omega dt, cos theta into sin omega dt. So, this is in the form of cos sin A cos b plus cos A sin b. So, therefore, C of t can be written as 1 minus e power of minus zeta omega n into t divided by root of 1 minus zeta square sin A plus b omega dt plus theta, where theta is the tan inverse of root of 1 minus zeta square divided by zeta from the above triangle. So, here this is the time response of underdamped system for unit step response as C of t is equal to 1 minus e power of minus zeta omega n t by root of 1 minus zeta square into sin omega dt plus theta. So, as usual it is also having two components. This is the steady state component, and this is the exponential decaying transient component having sine wave, exponential decaying transient component in the sinusoidal waveform. So, the graph can be drawn as shown. This is the time and this is the output C of t. So, the graph will be now. So, this is the step response, this is the actual step input what we are giving to the underdamped system. This is 1 and the graph will be now exponentially decaying transient wave. So, this is the this is settling time and this is a transient waveform, and it is observed that the response is oscillates before settling to a final wave. So, these are the oscillations before settling to the final value, and these oscillations are depending upon the value of damping ratio. Depending upon the value of damping ratio, these oscillations will be existing here.